Did you know that some of the objects that fall to Earth are actually older than our planet itself? In this audio course, I invite you to explore the origins of the solar system's most ancient meteorites. These are primeval fragments that existed before the planets, withstood tremendous collisions, and journeyed for billions of years before finally reaching us. We will delve into the secrets these relics from the dawn of our world contain, examining the oldest material humanity has ever handled, and uncovering the first chapters of our cosmic story. Meteorites are essentially space rocks that have endured a fiery passage through our atmosphere to land on the planet's surface. Their real importance, however, lies in their role as couriers from the distant past, carrying invaluable data about the era of the solar system's formation. Each one serves as a historical witness, and by analyzing them we can unlock mysteries that have been sealed away for many millions of years. It's common to get the terminology mixed up, so I want to clarify the distinction between meteoroids, meteors, and meteorites. Meteoroids are small celestial bodies drifting through the vacuum of space. When one enters our atmosphere and ignites, the resulting streak of light is what we call a meteor. Should any part of that object survive the descent and strike the ground, it then earns the name meteorite, with each term marking a distinct phase of its cosmic voyage. The solar system's story is a grand saga that started billions of years ago, and within this vast cosmic theater, meteorites were assigned a fundamental part. They served as the primordial building materials from which the planets, our own Earth included, were constructed. Without these ancient architects, our world's history would be unrecognizable. The very creation of our planet is inextricably linked to the journey of these spacefaring objects. To grasp how meteorites are created, it helps to picture them as byproducts of a massive cosmic workshop. When asteroids slam into each other or shatter, they produce these smaller fragments that can then drift through space for eons. In this way, meteorites are like the remnants of a great interplanetary construction project, each piece possessing its own unique history and set of properties, all part of a continuous process that illustrates the solar system's dynamic evolution. So, what can these cosmic stones tell us about the age of the Earth? You can think of every meteorite as a kind of time capsule. By studying their composition, scientists can determine when and how they originally formed, which provides the critical data needed to calculate our planet's age. This link is absolutely essential for comprehending our position in the cosmos and the immense span of time since Earth began its orbit around the Sun. Certain meteorites are exceptionally old, and their analysis has provided a wealth of information. Some of the most ancient specimens ever discovered are dated to be over 4 billion years old. These objects don't just captivate us with their immense age, they also offer a direct look into the conditions and events of the very early solar system. Just try to imagine the feeling of holding a fragment of the universe's own history in your hands. The isotopes contained within meteorites function much like a fingerprint, revealing their unique point of origin. Using these isotopic signatures, scientists can pinpoint where a meteorite came from and establish its relationship to other celestial bodies. This data is indispensable, as it helps us piece together not only the story of the meteorites themselves, but also the history of our own world and its neighbors. Water is another fascinating element connected to meteorites. It may surprise you to learn that some of these rocks contain water, either frozen as ice or locked within their chemical structure. This discovery has led researchers to theorize that meteorites may have been responsible for delivering water, the cornerstone of life, to a young Earth, fundamentally altering our models of planetary formation and the potential for life elsewhere. One of the most dramatic narratives involving meteorites is the giant impact theory. This hypothesis proposes that a colossal body, perhaps the size of Mars, collided with Earth, and the resulting debris eventually coalesced to form the Moon. This single monumental event didn't just give us our natural satellite. It also set in motion profound changes that shaped the future of life on our planet. Our world's trajectory would have been entirely different if this impact had never happened. Another compelling area of study is the link between meteorites and the emergence of life on Earth. A number of scientists have put forward the idea that these space rocks could have transported the fundamental organic compounds necessary for life to our world. This transforms them from simple messengers of the past into potential couriers of life itself, raising the profound question of whether earthly life might have extraterrestrial beginnings. Across the ages, meteorites have stirred the human imagination. From ancient cultures that viewed them as signs from the heavens, to modern researchers who scrutinize them to decode the universe's secrets. These celestial visitors have undeniably left a permanent mark on our culture and our scientific knowledge, profoundly influencing how we perceive our own place in the cosmos. The search for meteorites today is a thrilling pursuit that employs highly advanced techniques. Scientists utilize sophisticated instruments to find and examine these objects, which helps them decipher their composition and trace their origins. Furthermore, the exploration of other planets and asteroids has created new frontiers for discovering meteorites and gaining a deeper understanding of the forces that sculpted our solar system. By investigating worlds like Mars, for example, scientists have discovered evidence of meteorites that have landed on their surfaces. This research not only teaches us more about the red planet, but also broadens our perspective on how meteorites have impacted other bodies throughout the solar system. The concept of space mining, which has started to become a serious consideration in recent decades, also hints at the future value we see in these cosmic resources. Scientists and entrepreneurs are currently investigating how celestial bodies could unlock the next chapter of space exploration, given the potential for extracting resources from meteorites. This prospect introduces fascinating questions regarding the long-term viability of space travel and our capacity to leverage these materials for the betterment of all humanity. Throughout history, meteorite impacts have had profound consequences on our planet, ranging from cataclysmic events that reconfigured entire ecosystems to occurrences that shaped the trajectory of human civilizations. These cosmic collisions have undeniably left a lasting mark on Earth's story, which leads us to ask what we can learn from them to ensure our future safety. In response to this risk, the new field of planetary defense is dedicated to identifying and mitigating the threat of meteorite strikes on Earth. Scientists are diligently working to formulate strategies that would enable us to foresee these impacts and effectively shield our world. This represents a colossal challenge that demands global collaboration and highly advanced technology. The future of meteorite research holds incredible promise and excitement. As new space missions are planned and our technology continues to advance, we are poised on the edge of unprecedented discoveries about these captivating celestial wanderers. Each new piece of information has the potential to fundamentally alter our understanding of the solar system's origins and even our own existence, making one wonder what astonishing revelations lie just ahead. Meteorites are enthralling objects that journey through our solar system, and as they traverse Earth's atmosphere to land on its surface, they share tales from the distant past. To fully appreciate what they are, you must first become familiar with some related terminology. For example, meteors are the brilliant flashes of light you see in the night sky, which are commonly known as shooting stars. In truth, they are fragments of material burning up upon entering the atmosphere, creating a stunning luminous trail. On the other hand, you have meteoroids, which can be thought of as the smaller siblings of meteorites. These are chunks of rock or metal that float through the vacuum of space, Should they endure their fiery descent through the atmosphere and make it to the ground, they are then classified as meteorites. The essential distinction between a meteor, a meteoroid, and a meteorite lies in its location and stage of its journey. A meteoroid is the object in space. A meteor is the visible phenomenon of its atmospheric entry, and a meteorite is the physical object that reaches Earth's surface.
To make it clearer, picture a train journey. A meteoroid is like a passenger waiting at the station. A meteor is that same passenger speeding through a dark tunnel, and a meteorite is that passenger finally arriving at their destination. These celestial arrivals are categorized into three primary groups. There are stony meteorites, composed mostly of minerals, iron meteorites, which have a high concentration of metals like iron and nickel, and stony iron meteorites, which are a composite of both rock and metal. Each of these types gives us a singular view into the deep history of our solar system. You could think of it as assembling a massive puzzle of the universe's past, where every meteorite discovered is another piece helping you understand how planets and other cosmic bodies originally formed. Essentially, meteorites serve as time capsules, safeguarding information about the early solar system within their chemical composition and physical structures.
Furthermore, through the study of meteorites, scientists are able to ascertain the age of various celestial bodies. Analyzing these objects can provide clues about their formation dates, allowing us to construct a more precise timeline of the universe's evolution. This becomes particularly compelling when you consider that some meteorites are believed to be older than the Earth itself. Certain meteorites have journeyed through space for billions of years, and each carries its own unique history. A prime example is the Allende meteorite, which fell in Mexico in 1969, and has since provided immense insight into the formation of our solar system.
So, how do these objects become woven into our world's history? The majority of them start out as part of asteroids that orbit the Sun in the belt between Mars and Jupiter. When these asteroids collide, they fracture into smaller pieces, and the gravitational pull of planets can divert some of these fragments toward Earth. To put it simply, it's like shaking a bag of marbles where a few inevitably fall out. Each marble is a meteoroid, and if one happens to land inside your home, it becomes a meteorite.
The investigation of meteorites also introduces us to the fascinating concept of isotopes. These are different versions of a chemical element that share the same number of protons, but have a varying number of neutrons. By examining the isotopes within meteorites, scientists can deduce their origins and retrace the history of our solar system. It is as if every meteorite possesses a cosmic passport that details precisely where it came from and when it arrived on our planet. This search for meteorites is not confined to our own world. On Mars, for instance, researchers have discovered evidence of meteorites and have been able to study their distinct properties. Such findings not only expand our knowledge of Mars, but also contribute to a broader understanding of the solar system's complete history. Consequently, every single meteorite found has the potential to unlock doors to incredible new discoveries. An especially intriguing area of study is the link between meteorites and water. Researchers have found that some meteorites contain ice and other chemical compounds that might have been instrumental in the formation of water on Earth. This possibility raises profound questions about where our planet's water came from and what role it played in the emergence of life. It's possible these ancient rocks were the very messengers that delivered water to our world. Finally, when you contemplate meteorites, it is essential to recognize their deep-seated role in our culture and history. For centuries, these objects from space have captivated the human imagination, serving as the inspiration for myths, legends, and pivotal scientific breakthroughs. From ancient societies that venerated them as omens from the gods to modern scientists meticulously analyzing them in advanced laboratories, meteorites have left an indelible impression on our collective understanding of the cosmos. The next time you witness a shooting star streak across the sky, consider that you might be seeing a meteor on its final journey. Behind that fleeting flash of light is a story of cosmic proportions, told by the meteorites that have successfully reached our world. These celestial travelers carry profound secrets, and the answers they hold are locked within every fragment that falls from space, awaiting our discovery and comprehension. If this exploration of the cosmos fascinates you, and you wish to delve deeper into the universe's mysteries, I encourage you to subscribe and activate notifications. We can then journey together to answer questions like, how did our solar system come into being? And what part did meteorites play in that incredible process? To grasp the solar system's origins, we need to venture back to a time of pure chaos, imagining an immense expanse filled with gas and dust where collisions were the norm. In this primordial theater, meteorites acted as cosmic sculptors, their influence shaping the home we know today. These pieces of rock and metal that land on Earth, which we call meteorites, are in fact fragments from an incredibly distant past. They played a vital role during the solar system's formation, a process that began around 4.5 billion years ago. Meteorites were ubiquitous, forming a crucial part of the great material mosaic from which the planets, moons, and asteroids would eventually coalesce. But how did such small bodies exert such a monumental influence on the creation of entire worlds? The whole story starts with a massive cloud of gas and dust, which, for reasons still under scientific investigation, started to collapse under its own gravity. As this cloud condensed, it formed a spinning disk with our sun beginning to ignite at its center, while the surrounding material began to clump together. It is at this stage that meteorites entered the narrative. Through a mechanism known as accretion, tiny particles of matter merged to create progressively larger objects in an environment where constant collisions were the engine of celestial creation. Beyond being the raw material for planet formation, meteorites also served as direct witnesses to the solar system's unfolding history. By analyzing these ancient fragments, scientists can reconstruct the timeline of events that led to the birth of Earth and the other planets. For instance, some meteorites contain chemical elements forged in the solar system's infancy, offering invaluable clues about the conditions that prevailed at that time. In this way, meteorites function as cosmic time capsules, transporting our understanding back to an era when everything was still taking shape. One can think of the solar system's history as a colossal puzzle, where each meteorite represents a single piece that, when fitted into place, clarifies a new facet of this intricate past. When one of these pieces strikes a planet, the consequences are astonishing. It doesn't just leave a physical scar on the surface. It can also fundamentally alter the planet's chemical composition. This was particularly significant for Earth, where it's believed that meteorites delivered some of the essential ingredients that allowed life to emerge. It is important to realize that not all meteorites are alike. They come in various types with significantly different compositions. Some are primarily metallic, while others are mostly composed of stone. This very diversity allows us to comprehend the different processes that occurred throughout the developing solar system. In this sense, analyzing the distinct pieces of the meteorite puzzle reveals not only their own origin stories, but also sheds light on the history of other celestial bodies. To understand the context of their formation, let's consider the bodies that never quite became planets. As the planets were solidifying, some matter remained as asteroids, which, due to their smaller size, have a much higher likelihood of colliding with one another. These collisions frequently produce the fragments we recognize as meteorites, making them the resilient survivors of a formation process that many other celestial bodies did not complete. Over countless millennia, a fraction of these survivors have found their way to Earth, compelling us to ask what secrets they carry. Every meteorite that falls to our planet
presents a new chance to learn more about the history of our solar system. By examining its composition, scientists can trace its origin and understand its formation, which in turn deepens our knowledge, not just of our own beginnings, but of other planets as well. Furthermore, meteorites offer us crucial information about the distribution of water in the solar system, as certain types contain water compounds. This evidence suggests that water may have been delivered to a young Earth by these cosmic travelers. This possibility raises compelling questions about how life began on our world. If meteorites were responsible for bringing both water and other vital chemical compounds, is it possible they also carried the very seeds of life itself? Ultimately, the solar system's history is a narrative of profound interconnectedness, where every meteorite, every impact, and every cosmic event has contributed to the reality we see today. Just as they shaped our planet's geology, meteorites have also left an indelible mark on human culture, fascinating people since ancient times, and inspiring countless myths and legends. Our search for meteorites is driven by more than just scientific curiosity. It is a way to learn about ourselves and our unique position in the universe. By studying these fragments from space, we not only unravel the solar system's greatest mysteries, but also forge a deeper connection with the long history of our own planet. They are, without a doubt, a window into our past and an essential guide for understanding our future. Meteorites are defined as fragments of rock and metal that endure a fiery passage through Earth's atmosphere to land on the surface. But have you ever paused to think about how these small cosmic voyagers actually reach us? To find the answer, it's crucial to know that meteorites are not random occurrences. They are the end result of fascinating and incredibly complex cosmic processes. The life story of any given meteorite begins far from here, within the vast, silent expanse of space, where innumerable rocks drift through the void. A number of these rocks find their origins in asteroids, which are larger celestial bodies that orbit the Sun, mostly within what you know as the asteroid belt, located between Mars and Jupiter. You can picture this as a massive region of cosmic rubble, where every single piece possesses its own unique story. When these asteroids collide, they can shatter, sending fragments adrift through the cosmos, with some eventually finding a trajectory toward our planet. Upon entering our atmosphere, the intense heat and friction cause most of these fragments to burn up, creating the brilliant streaks of light you might recognize as shooting stars or meteors. However, certain larger pieces are resilient enough to survive this fiery descent and reach the ground, at which point they are known as meteorites. This naturally leads to the question of what distinguishes a meteor from a meteorite. The distinction is all about where you encounter it. A meteor is the luminous phenomenon you observe in the night sky, whereas a meteorite is the tangible object that has completed its journey to Earth. Think of it as being similar to bowling, where the ball represents what you see moving through the air, but the pin it strikes is the final destination. Once a meteorite has landed, its story is far from over. In fact, an entirely new phase of its existence begins. For scientists, these extraterrestrial visitors are invaluable, as they provide a direct glimpse into the deep history of our solar system, and researchers are always keen to get their hands on them. To grasp how a meteorite is formed, it helps to consider the very creation of planets. Billions of years ago, a vast cloud of gas and dust started to collapse and spin, eventually giving rise to the Sun and the planets. Meteorites came into being during this chaotic period, formed from the residual material that never managed to coalesce into larger planetary bodies. Each one tells a distinct tale through its composition, which can differ significantly from one to the next. Some of these celestial objects are composed primarily of metals like iron, while you will find others that consist of various rocks and minerals.
This incredible variety brings up another fascinating query. What can these fragments reveal to us about the beginnings of our solar system? In essence, meteorites serve as cosmic time capsules, preserving information about the materials and environmental conditions that were present in space eons ago, allowing scientists to piece together the history of Earth and its celestial neighbors. The creation of a meteorite is not a haphazard event. Specific cosmic processes dictate what each one is made of. For instance, some meteorites are derived from the crust of asteroids, whereas others might be remnants of comets. This diversity in their origins is fundamental to helping you understand the many different classifications of meteorites we find. In simpler terms, you can view a meteorite as an emissary from the distant past, delivering narratives from far-off corners of space. Moreover, the circumstances under which meteorites are forged are often extraordinary. During their formation, these fragments can be subjected to immense temperatures and pressures, transforming them into veritable treasures from space. They contain priceless data regarding the chemistry and physics of the parent bodies from which they were violently separated, making them incredibly important for scientific study. Once a meteorite has survived its atmospheric entry and impacted Earth, it becomes the focus of intense scientific inquiry. Researchers employ sophisticated techniques to dissect its makeup and trace its origins. This analytical process frequently involves mass spectrometry, a method that enables them to precisely identify every element contained within the meteorite, giving you a detailed chemical fingerprint. Understanding a meteorite's composition is so crucial because every new find can offer clues about how other celestial bodies were formed, which in turn deepens our knowledge of our solar system's own history. Meteorites are also essential for helping us comprehend the evolution of our own world. By examining these space rocks, you allow scientists to learn about the conditions that prevailed during Earth's infancy, long before life as we know it existed. It's truly remarkable when you consider that a simple piece of rock can unveil so much about our collective past, almost as if each one harbors an ancient secret just waiting for us to uncover it. But the fascination with how meteorites are formed doesn't stop with what we already know. As researchers continue their explorations, every fresh discovery has the potential to unlock entirely new lines of questioning. For instance, could it be possible that some meteorites carry the essential chemical building blocks for life? The answer to this question is not only profoundly interesting, but also holds the power to reshape your entire understanding of how and where life might emerge throughout the universe. It suggests that the seeds of life might be more widespread than we ever imagined, traveling between worlds on these cosmic messengers. Ultimately, the process of meteorite formation is a magnificent phenomenon that connects you directly to the immensity of the cosmos. These chunks of rock and metal are more than just inert objects. They are couriers bearing vital information about our solar system's past. Every meteorite that lands on Earth presents a chance for you to learn, to explore, and to contemplate our own place within this vast universe. So, the next time you witness a shooting star, I hope you'll remember that its brief flash conceals a story that has journeyed across space to reach you. This brings us to a compelling question. What can meteorites reveal about the actual age of our planet? It's an inquiry that encourages you to explore a realm where the histories of Earth and the solar system are woven together in the most amazing ways. We tend to see our planet as a static, unchanging place, but the truth is that it is in a state of constant flux and evolution. These travelers from space might just be the puzzle pieces you need to understand not only how our world formed, but also how long ago that happened. When you think about meteorites, it's easy to just picture rocks falling from the sky. But I wonder, did you know that some are like time capsules holding invaluable information about the distant past? Through studying them, scientists have found that many meteorites are actually older than Earth itself.
This incredible fact means that by analyzing their composition, you can effectively look back to the very birth of the solar system and comprehend how and when the planets came to be. To give you a better sense of this, try to envision the history of our world as a grand book. If you were to open it, meteorites would represent the very first pages, chronicling a time before the formation of continents and oceans. Scientists can determine the age of these primordial rocks using techniques like radiometric dating. This method works by measuring the decay of specific radioactive isotopes found within the meteorites, allowing for an incredibly precise calculation of their age. This offers us a glimpse deep into the past, revealing that certain meteorites have existed for more than 4.5 billion years. But you might wonder, why does determining their age matter so much? The significance is found in the link between these cosmic travelers and the birth of our solar system, as meteorites are essentially the leftover material that never consolidated into planets. Think of them as the remaining crumbs from a vast cosmic banquet, and by examining them, we gain insight into the formation of Earth and its planetary neighbors. Determining the age of these objects helps us pinpoint when different celestial bodies came into being and understand how matter was scattered throughout early space. Consider meteorites to be like ancient footprints preserved in time. Each one tells a story, and by studying them collectively, we can reconstruct the history of our cosmic neighborhood. In this way, meteorites serve as quiet observers of the era when the sun, the planets, and other celestial objects were still taking shape. Through the analysis of their composition and features, scientists can deduce the conditions of the environments where they originated and understand their connection to our own planet's story, providing us with crucial evidence regarding Earth's geological past. For instance, specific meteorites carry isotopes of elements like oxygen and carbon that were created under very particular cosmic conditions. When we compare these isotopic signatures to those found here on Earth, we can learn more about how and when our atmosphere and oceans appeared, and even trace the source of the elements that constitute life itself. This journey into the past allows meteorites to help us tackle fascinating questions about the evolution of life on our world. By examining the circumstances of their formation, researchers can theorize how these very same elements may have played a role in the dawn of life. It's almost as if meteorites possess a form of cosmic DNA, a code that narrates the story of how the essential building blocks of life were delivered to our young planet. And what can be said about the meteorites that have actually impacted our world? These collisions have left indelible marks on Earth's history, with some aligning with pivotal turning points in life's evolution. A prime example is the colossal impact thought to have occurred around 65 million years ago, which led to the extinction of the dinosaurs. By studying the fragments of these impactors, scientists can better grasp how such events have shaped the trajectory of life over vast spans of time. It's truly remarkable to realize that when you gaze at the sky and spot a meteorite, you are peering directly into the past, back to an epoch when our solar system was just beginning to form. Every single meteorite that lands on Earth presents a new chance to expand our knowledge of our own history, with each finding drawing us nearer to a deeper comprehension of our position in the cosmos. The relationship between meteorites and Earth's age remains a field rich with unsolved puzzles. With advancing technology and the development of new analytical techniques, we are poised to discover answers to questions that we haven't even formulated yet. These celestial messengers not only bear witness to our history, but could also hold the very key to deciphering the mysteries of our future. Ultimately, you can think of meteorites as individual pages in an ancient tome, each one brimming with tales waiting to be read. They inform us about the birth of our solar system, the chronicles of Earth, and the pivotal events that molded our world.
So, the next time you witness a shooting star, keep in mind that you're observing a piece of our universe's story, a narrative that continues to unfold. Across the immense expanse of the universe, there exist relics of history that have journeyed through space for billions of years, and some of the oldest meteorites known to us are genuine cosmic treasures. Their exceptional value comes from their capacity to tell us about the dawn of the solar system, which in turn reveals the earliest chapters of Earth's own story. Let's begin with a particularly notable example that has captivated both scientists and enthusiasts, the Allende meteorite, which landed in Mexico in 1969. This meteorite gained fame not just for its dramatic arrival, but because it holds some of the most ancient materials ever identified in our solar system. It is incredible to consider that these fragments were drifting through space before our own planet had even formed. So, what specific qualities define a meteorite as being ancient? Generally, scientists assess its chemical makeup and its physical structure. The most primitive meteorites frequently contain isotopes of elements that were created during the very first phases of the solar system's existence. This quality transforms them into veritable time capsules, preserving data from the exact period when the planets were coalescing. The Murchison meteorite, which fell in Australia in 1969, serves as another remarkable case. This specific space rock offered evidence that organic compounds can form in the cosmos, which implies that the fundamental components of life might have originated out in space before ever arriving on Earth. It's astounding to think that an unassuming piece of rock could hold such profound secrets about the genesis of life. Meteorites are also categorized according to their composition, which can be iron, stony, or a fascinating mix of both, a diversity that speaks volumes about their origins. Chondritic meteorites, for example, are regarded as some of the most primordial, helping us to understand the environment of the early universe. These can contain minute mineral spheres called chondrules, which are tiny time capsules that locked in information about the temperature and pressure of space when they formed, giving us a direct look at the conditions that existed as our solar system and other celestial bodies took shape. You can think of meteorites as cosmic time capsules, telling us tales about the universe. But what exactly are the secrets that these spacefaring rocks reveal upon reaching Earth? One of the most captivating aspects they contain is information about isotopes, which are essentially different versions of chemical elements that share the same number of protons, but have a varying number of neutrons. To make this clearer, you might imagine isotopes as different flavors of the same ice cream. While they are all fundamentally ice cream, each one possesses a distinct character. When scientists examine the isotopes within a meteorite, they can uncover specific details about where it came from, almost as if you could follow a traveler's journey just by analyzing their footprints. These elemental signatures are like traces frozen in time, allowing us to reconstruct the solar system's distant past. Let's consider a specific example: carbon. This element, so crucial for life on our planet, is also found in numerous meteorites, and by studying the ratios of its isotopes, scientists can learn about the chemical environment of space billions of years ago. It's akin to exploring the components of an ancient recipe preserved for generations. Similarly, hydrogen isotopes play a pivotal role, as their analysis helps unravel the story of water in our solar system, suggesting it may have been present elsewhere long before it arrived on Earth. In addition, isotopes of elements like nickel and iron offer their own valuable insights, telling stories about the conditions in space where these common metals were forged. When we compare the isotopic signatures of meteorites with those found on Earth, it's a bit like contrasting two friends who grew up together but followed different life paths. This comparison helps scientists determine if the materials that built our world originated from the same source as these meteorites, though you should know the process is far from simple.
A great number of these celestial visitors originate from the asteroid belt located between Mars and Jupiter, a fact that provides a direct link to understanding the wider history of our solar system. By analyzing them, scientists can piece together the history of their parent asteroids, the collisions that shattered them, and how these powerful events sculpted our cosmic neighborhood. Each meteorite is like a single piece of a cosmic puzzle, bringing us closer to seeing the complete picture. Furthermore, the investigation of ancient meteorites has completely transformed our grasp of chemistry in space. Through examining the compounds locked within these rocks, researchers have found that some of the very same elements composing life on Earth are also present out in the cosmos. This discovery poses a truly compelling question. Could meteorites, in a way, be carriers of life that might have emerged somewhere else in the universe? Some meteorites are even more prized because they harbor minerals that are exceptionally rare on our world, which can offer clues about the extreme conditions that once prevailed in space. Beyond this, one of the great revelations is their part in the formation of planets. It is now believed that these celestial objects were crucial to the process of accretion, where small particles gradually combine to create larger bodies, making meteorites an integral part of Earth's own creation story. Isn't it incredible to consider that every meteorite streaking through our atmosphere is delivering a story from the universe? Research has also shown that some of them contain water, which opens up new possibilities for the existence of bodies of water on other planets. As unbelievable as it might sound, these rock fragments have been essential to our comprehension of how water could have been distributed throughout other parts of the solar system, not just on Earth. To sum it all up, the most ancient meteorites are far more than simple rocks from space. They are truly time capsules that give us a glimpse into the birth of the solar system and the chronicle of our own planet. Every single meteorite has its own narrative, and by deciphering them, we slowly unlock the secrets of the cosmos. So, the next time you happen to see a meteorite, please remember that you are looking at a fragment of cosmic history. It serves as a powerful reminder that while Earth is our home, we are all part of a much grander saga, a story that started billions of years ago and unfolds to this day. These ancient meteorites represent a physical connection to our past, and studying them not only helps us understand where we came from, but also provides hints about where we might be going. On occasion, isotopes can present contradictory data, much like reading a book where some pages dispute what is written on others. Within the study of meteorites, these discrepancies spark debates and inspire new hypotheses regarding the formation of our solar system. This serves as a potent reminder that science is a perpetually advancing discipline, brimming with mysteries still waiting to be solved. The role of isotopes also extends to the dating of meteorites. Scientists employ specialized techniques to calculate a meteorite's age by examining the proportion of specific isotopes, a process analogous to estimating a person's age by the lines on their face. Through this method, we can determine the vast expanse of time that has elapsed since these cosmic objects originally came into being. The investigation of isotopes within meteorites is not merely a matter of scientific curiosity. It holds significant ramifications for the future. A deeper comprehension of their isotopic makeup could reshape our strategies for space exploration and the quest for resources on other worlds. It's conceivable that one day, these tiny celestial fragments will teach us how to harness asteroid resources to support life on our own planet or within colonies on the moon. Ultimately, you can think of the isotopes in meteorites as the universe's unique fingerprints. Every single one narrates a distinct tale that deepens our understanding of the history, current state, and perhaps the destiny of our world and everything beyond it. When we analyze these elements, we are doing more than just stargazing.
we are actively investigating our own position within the immense cosmos. A thrilling expedition where meteorites lead the way on an intergalactic quest that has only just begun.
Have you ever gazed up at the night sky and questioned the source of the water that blankets so much of our planet? The link between meteorites and the solar system's water is a captivating subject, offering insights into the genesis of not just our world, but other cosmic bodies as well. In this story, meteorites assume a central role as couriers from deep space, delivering hints about the chronicle of water and its spread throughout the cosmos. These fragments of rock and metal, which have journeyed through the void for eons, can harbor water in surprising ways. How can a stone from space possibly carry something as fundamental as water? The secret is found within its chemical structure. A large number of meteorites, particularly those from asteroids, are composed of minerals capable of trapping water molecules, and these are known as carbonaceous meteorites. They function as miniature time capsules, revealing stories about the environment of the nascent solar system. If you picture the solar system as a vast kitchen, assembling the masterpiece we call Earth, then meteorites are the chefs, delivering the crucial components. Among these deliveries are compounds that, upon mixing, create water. Scientific findings have revealed that these meteorites took in water in the extreme cold of space during their formation, which implies that water was likely a feature of the solar system from its earliest moments. So, how does this connect to the water on our own planet? Is it possible that it was delivered here by meteorites? This question stands as one of the most compelling puzzles in the field of astrobiology. A prevailing belief among many researchers is that during Earth's formative period, a continuous downpour of meteorites could have transported a substantial volume of water. This phenomenon, like a cosmic deluge, likely played a pivotal part in creating our oceans and rivers, ultimately transforming Earth into the vibrant world we inhabit. Modern research highlights a particular class of meteorite, known as a C-type, which contains water with a composition remarkably similar to that in Earth's oceans. This discovery has prompted scientists to propose that these very meteorites were a primary contributor to our planet's water supply. You can envision a scenario where, instead of ordinary rain, the heavens delivered pieces of a cosmic puzzle that assembled into the vast oceans that define our world. The narrative of water, however, extends far beyond Earth. Other worlds, including Mars and the moons orbiting Jupiter and Saturn, also display evidence of water. Meteorite analysis has allowed scientists to find that some of these locations might have once possessed the right conditions to hold water. This leads to an even more captivating inquiry. Could life be present elsewhere in our solar system? Since water is considered an essential prerequisite for life, its confirmed presence on other planets elevates the probability that life could indeed be found there. Investigating the link between meteorites and water also encourages us to contemplate the future. Should humanity ever pursue the colonization of other planets, comprehending how meteorites supplied Earth with water could be the crucial first step to locating resources on new worlds. It's possible we could learn to utilize meteorites to provision our extraterrestrial settlements, effectively turning them into a network of cosmic supply stations. It's a remarkable thought that within this immense universe, meteorites serve as our connection to distant worlds. Each time one impacts our planet, it is akin to a piece of another realm arriving to share its history. Through the examination of these objects, scientists are attempting to unravel the origins of not just water, but of life itself. Additionally, certain meteorites have been discovered to carry organic compounds, the very foundation of living organisms. This finding has given rise to hypotheses that meteorites could have planted the seeds of life on Earth by delivering essential ingredients from outside our world. The notion that life itself was brought to Earth by these cosmic couriers is a groundbreaking idea that remains a subject of vigorous scientific discussion. The hunt for meteorites has also yielded some unforeseen results. On several occasions, researchers have identified ice within meteorites that have landed on Earth, which confirms that water is present in multiple forms throughout space. This ice, in turn, offers valuable clues regarding the initial formation of water in the solar system and its subsequent distribution across vast distances in time. As technology progresses, we are gaining new ways to investigate meteorites and the water they contain. Researchers employ spectroscopy, alongside other contemporary instruments, to break down the chemical makeup of these cosmic objects, which in turn yields priceless data about their origins and link to water. Every fresh finding adds another piece to the grand puzzle, deepening our comprehension of both our own past and the story of the cosmos. The link between meteorites and water is a powerful reminder that the cosmos is filled with endless surprises. Whenever you see a falling star, you're truly witnessing a fragment of history that has journeyed across the vastness of time and space. So the next time you spot one streaking across the sky, remember that it might be a bearer of water, and perhaps even life, acting as an open door to exploration in this immense and enigmatic universe. These celestial travelers continually remind us how much we still have to discover about our planet's origins and our own place within it all. Among the most thrilling and intricate narratives concerning the birth of our world and its companion, the Moon, is the giant impact theory. At its core, it suggests that in the nascent stages of our planet's existence, a colossal object, roughly the size of Mars, crashed into the early Earth. This cataclysmic collision fundamentally altered our understanding of the planet and was the pivotal event that led to the formation of the Moon. Can you even conceive of an object that massive slamming into our world? The resulting explosion would have unleashed energy comparable to millions of nuclear bombs. While this situation might sound like it belongs in a science fiction film, it is actually supported by a solid foundation of scientific proof. Through the examination of meteorites and the analysis of moon rocks returned by the Apollo missions, researchers have discovered striking similarities in the chemical makeup of both Earth and the Moon, pointing to a shared genesis. This collision wasn't just a defining moment in our planet's past. It was also instrumental in creating the very environment where life could eventually flourish. Following the immense impact, Earth became a molten sphere, an ocean of magma that required a vast amount of time to cool and solidify. This is precisely where meteorites become so valuable, as these cosmic voyagers have silently observed the solar system's evolution for eons, allowing scientists to reconstruct what our world was like both before and after the collision. Let's consider the chain of events that followed. After the impact, the ejected material started circling the Earth, creating a massive ring of debris that gradually coalesced into the Moon. This collision also had a profound effect on our planet's spin, ultimately setting the length of our day and night as we experience them now. Yet, the narrative continues, because meteorites, as enduring fragments of celestial objects, provide us with a unique record of the conditions that prevailed in space during that chaotic era. By dating certain meteorites, we've gained clues about the timeline for the formation of the Earth and Moon. For instance, analysis of specific meteorite types has led scientists to estimate that the Great Impact took place roughly 4.5 billion years ago, years in the past, offering us a glimpse into a time period that is nearly impossible to comprehend. It's remarkable to realize that these pieces landing on Earth, many too small to see, are in fact envoys from a distant past. These messengers are remnants from the age of planetary formation, meaning when you hold one, you are literally holding a piece of our solar system's origins. Furthermore, meteorites offer us a direct look into the early chemistry of our solar system. The fact that some of these rocks contain water and organic molecules is especially fascinating.
This raises one of the most compelling questions in science. Is it possible that meteorites delivered the fundamental components for life to our planet? The link between these celestial objects and Earth's water is a vibrant field of study that holds the potential to completely reshape our knowledge of life's beginnings. The giant impact theory also compels you to consider just how fragile our world is. If a collision of that scale was responsible for shaping both the Earth and the Moon, it makes you wonder what the consequences would be if such an event were to happen now. This is why scientists are constantly monitoring the skies for any asteroids or comets that might present a danger, making planetary defense a crucial discipline in an age where we must learn to safeguard our home. The tale of the giant impact serves as a powerful testament to the fact that the universe is a constantly evolving and dynamic environment. Each meteorite that lands on our planet is a portal to the past, holding a narrative that is waiting to be uncovered. So when you next witness a meteor, consider all it has survived and the part it played in shaping our world. Examining these objects from space not only illuminates our history, but also equips us for what lies ahead, helping us to appreciate the intricate tapestry of life on this planet. So, whenever you encounter news about meteorites, I want you to recall that they represent far more than simple space rocks. They are the surviving fragments of a cataclysm that sculpted our world, and in some profound way, they link all of us together in the grand, enigmatic dance of the cosmos. And in this cosmic ballet, one question continues to fascinate scientists and dreamers. Could a single meteorite have been the very key that opened the door to life on our planet? This concept, which may initially seem like something from a science fiction novel, is actually grounded in modern scientific inquiry. I invite you to join me on an exploration of this captivating hypothesis, which proposes that meteorites, those small fragments of rock and metal journeying through space, could have served as couriers, delivering the essential components for life to our planet. To grasp how this could be feasible, you must first recognize the fundamental elements that constitute life as we understand it: carbon, hydrogen, oxygen, and nitrogen. It's remarkable that a great number of meteorites are rich in these very elements. This raises a profound question. Could these ancient cosmic wanderers have transported the foundational building blocks required for living organisms to emerge? Scientific investigation has revealed that specific meteorite types, like carbonaceous chondrites, are not just abundant in these elements, but also carry amino acids, which are the molecules that assemble into proteins. Proteins are absolutely essential to life, performing roles as structural materials, biological catalysts, and carriers of information. Therefore, if meteorites were capable of delivering amino acids to early Earth, it's conceivable that the earliest life forms were the product of a cosmic shipment. Try to envision the scene on primitive Earth, a world defined by intense volcanic activity and exceedingly harsh conditions. Into this chaotic environment, meteorites might have crashed, introducing these crucial ingredients. It would have been akin to receiving a vital care package in the midst of a planetary tempest. This delivery, however, was just the beginning of a process governed by competition and adaptation. The critical question then becomes how these delivered compounds eventually transformed into life. The prevailing theory suggests that the organic materials from meteorites, when met with the right terrestrial conditions, could have initiated a cascade of complex chemical reactions. These reactions, in turn, may have paved the way for more intricate structures, such as the first cells, to form in a gradual process, much like putting together a vast and intricate puzzle. If meteorites were indeed responsible for supplying these materials, it leads to another compelling thought. Could they be considered the progenitors of life on our world? This idea expands into an even more exciting possibility. If this process happened here, it could potentially occur on other planets as well. With thousands of exoplanets discovered throughout the cosmos, the notion that other worlds may have received similar packages of life truly sparks the imagination. In laboratory settings, scientists have simulated the conditions of primordial Earth, combining organic compounds and subjecting them to energy sources like ultraviolet radiation or electrical sparks. Through these experiments, they have successfully synthesized amino acids and other basic life components. This demonstrates that while meteorites could have been a key factor, life might also be a phenomenon that arises naturally when the circumstances are right. Pushing this idea further, some researchers theorize that certain meteorites might have harbored actual microbial organisms within them. This concept, known as panspermia, explores the astounding possibility that life is not confined to Earth, but is instead an interplanetary occurrence, capable of traveling from one world to another. Such a revelation would completely reshape our understanding of life in the universe. Of course, the reality is not quite so straightforward. The complexity of life as we know it is immense, and for the ingredients delivered by meteorites to develop into living entities, a supportive environment is indispensable. The unique conditions of the early Earth, including its specific atmosphere and temperature range, were undeniably critical to this transformation, raising doubts about whether meteorites can be given sole credit for life's origin. The puzzle of the link between meteorites and the genesis of life remains a vibrant area of scientific research. Every new finding moves us closer to a complete picture of how it all began, yet many questions persist. For instance, a key challenge is confirming that meteorites arriving on ancient Earth truly carried these life-giving ingredients, a mystery that might be unraveled by studying meteorites found on other worlds, like Mars. The fascination with this potential connection extends beyond the scientific community, prompting you to contemplate your own place in the universe. If meteorites did in fact play a part in bringing life to this planet, it means every one of us shares a profound cosmic heritage. The next time you gaze up at a star-filled night sky, consider that those distant lights might be tied to the very story of your existence. Throughout this cosmic journey, we have examined the intriguing possibility that meteorites were instrumental in the creation of life on Earth. While science has a long road of discovery ahead, one thing is clear: our universe is brimming with unexpected wonders. It's vital that we continue our search and keep posing questions, because each new answer only leads to deeper inquiries and a richer appreciation of our role in this vast, mysterious cosmos. For as long as humans have existed, meteorites have been a part of our world. Yet their influence on our culture, science, and perception of the universe is often overlooked. Since antiquity, these objects from the heavens have captivated humanity, giving rise to countless myths and legends. It's worth asking how a simple piece of space rock could leave such an indelible mark on our collective history. Humanity's relationship with meteorites is as ancient as civilization itself. Many early cultures viewed them as divine messages or sacred artifacts. In ancient Egypt, for instance, a stone that fell from the sky was regarded as a gift from the gods. This wasn't merely superstition. These meteorites were often fashioned into valuable tools and ornaments, highlighting their practical as well as symbolic importance. Across the ages, meteorites have served as silent observers of pivotal human events. During the Middle Ages, they were often interpreted as dire omens foretelling disaster. Consequently, whenever a celestial body was seen falling to Earth, communities would hold elaborate ceremonies in an attempt to pacify their deities and avert catastrophe. In this way, meteorites served not merely as stones, but as powerful symbols connecting the mortal realm with the divine. Science, in turn, has been profoundly captivated by these visitors from the cosmos. and the dawn of the scientific revolution ushered in a new way of thinking about them. Did you know that some of the very first scientific inquiries into meteorites contributed to establishing the theory that our planet is not the center of the universe? This prompted scientists to challenge established dogmas and delve into the true nature of these cosmic objects.
As researchers gathered more data, meteorites came to be recognized as crucial clues for unraveling the formation of our solar system. The discovery of their extraterrestrial origin marked a true turning point in this history. Up until the 19th century, the prevailing belief was that they were just ordinary rocks thrown from mountains or volcanoes. However, when pioneers like the German scientist Ernst Chladni began their investigations, they concluded these were actually pieces of asteroids and other celestial bodies, a revelation that fundamentally altered our understanding of the cosmos and Earth's position within it. The reach of meteorites extends far beyond the scientific field, as these objects have also ignited the imagination of artists for generations. Creative minds, including painters, authors, and directors, have consistently found deep symbolism within them. In literature, for instance, meteorites often appear as omens of profound change, famously exemplified in H.G. Wells' science fiction classic, The War of the Worlds, a tale that illustrates how a confrontation with the extraterrestrial can force you to reevaluate humanity's role in the universe. Even in the world of technology, meteorites have made a surprisingly significant impact. Meteoritic iron, prized for its exceptional quality and resilience, was historically forged into superior swords and tools. This unique metal was highly regarded across various cultures, where it often became a symbol of great power and high status. As we've progressed into the modern age, our fascination with meteorites has only intensified, fueling numerous expeditions to the planet's most remote corners, as scientists eagerly seek to analyze every new fragment they find. The search for meteorites is more than a scientific quest. It's a profound connection to the distant past, and a key to decoding the history of our solar system. The scientific community now recognizes that these space rocks might harbor clues about the existence of life on other worlds. Some hypotheses propose that meteorites could have delivered the essential ingredients for life to a young Earth. Just consider the monumental shift in our cosmic perspective if we were to find that life as we know it has origins beyond our own planet. Meteorites have officially secured a firm place in popular culture, where their depiction in movies and video games has changed considerably over the years. Frequently, they are portrayed as dangerous, destructive forces, which speaks to a deep-seated human fear of the unknown. At the same time, they can be represented as catalysts for progress and transformation, compelling us to gaze at the stars and envision the possibilities of the future. Ultimately, the long history of meteorites is a reflection of humanity's own unquenchable curiosity. From antiquity to today, our engagement with these celestial objects has driven us to investigate the cosmos and contemplate our own existence. Each meteorite that lands on Earth is a tangible reminder of our connection to a universe whose vastness we are only just beginning to grasp. As our technology advances, our capacity to probe these objects in greater detail will expand, promising a future where the study of meteorites only intensifies. Who can say what mysteries these cosmic travelers still conceal, just waiting for us to uncover them? Examining these celestial fragments not only enhances our scientific understanding, but also serves as a lasting source of inspiration for artists, thinkers, and dreamers everywhere. The story of meteorites and their effect on civilization is a powerful testament to our innate capacity for wonder and exploration. Every stone that falls from the sky is an invitation for you to ponder your own place in the infinite expanse of the universe, bringing us closer to understanding both their origins and our own. The hunt for meteorites is a thrilling endeavor that blends scientific inquiry with adventure and a touch of fortune. When you see a shooting star streak across the night sky,
You are witnessing a meteor, a tiny piece of space debris burning up as it enters our atmosphere. But what becomes of the fragments that survive this fiery descent and reach the ground? This very question marks the beginning of an exciting search, where you must determine if a find is a genuine meteorite or simply an earthbound rock. To locate these celestial treasures, scientists employ a range of techniques, from meticulous sky observation to organized expeditions in deserts and polar landscapes. Picture yourself on a team venturing into Antarctica, where the stark white canvas of snow and ice makes dark meteorites stand out like scattered jewels. In such a desolate environment, every rock discovered has the potential to narrate a story that is billions of years old.
One of the most compelling questions is how experts can be absolutely certain they've found a genuine meteorite. A set of established criteria guides the identification process, beginning with an assessment of the object's physical properties. A meteorite typically feels much denser than a normal rock and might feature a smooth, melted crust from its atmospheric passage. Furthermore, they often contain metals, like iron and nickel, in combinations rarely seen in terrestrial stones. Beyond these initial checks, an even more fascinating step involves modern chemical analysis and spectroscopy to precisely map a meteorite's composition. These methods not only confirm its extraterrestrial nature, but can also help trace its specific origin point within the solar system. It's truly remarkable to consider that a small stone in your hand could be a messenger from deep space, carrying with it vital information about the birth of our planetary neighborhood. In addition to these active searches, meteorites are also found at impact sites, where a fall leaves behind not just a crater, but often pieces of the original object as well. This research has yielded some truly extraordinary findings, such as in the Arizona desert, where the Barringer crater, often called Meteor Crater, tells the story of an impact from nearly 50,000 years ago. Yet, prime search locations are not limited to deserts. Scientists have also uncovered meteorites in the most unlikely of places, including the deep ocean, which makes you wonder just how many of these cosmic stones are resting undiscovered on the seabed, posing a compelling question. How many more await us here on Earth? Advancing technology is now playing a pivotal role in the hunt for these celestial objects. Researchers employ tools like drones and satellites to perform aerial surveys, allowing them to pinpoint areas of interest where meteorites may have landed. This approach transforms the search into a far more efficient process, reducing its reliance on mere chance and demonstrating how science continually progresses, with each new find potentially reshaping our cosmic perspective. Another thrilling element of this pursuit is the emphasis on international cooperation. It's common for researchers from various nations to collaborate, sharing their data and physical samples. You can picture a team of scientists from all corners of the globe, assembled in a single lab to analyze a meteorite that journeyed millions of kilometers to reach them. This is a brilliant illustration of how the quest for knowledge unites people across different cultures. However, the search for meteorites is certainly not without its difficulties. Scientists must contend with challenges ranging from extreme weather and scarce resources to, at times, considerable bureaucracy. For instance, securing the necessary permits to explore for meteorites within protected territories in certain countries can be an exceptionally complicated affair. But persistence is absolutely essential, and the promise of discovery motivates many researchers to navigate these hurdles. Every single meteorite recovered is a scientific treasure, holding clues to the history of our solar system. Once a meteorite is found, it undergoes a meticulous process of cataloging and study. Each analysis can reveal vital information about its chemical makeup, its age, and sometimes the very events that forged it into a meteorite. This wealth of data sheds light on the early solar system, the formation of planets,
and the evolution of celestial objects over eons.
This work prompts another captivating question. In what ways can meteorites alter our conception of the universe? By delving into their origins and composition, we start to assemble the narrative of how planets took shape, which ultimately leads us to understand how our own Earth came to exist. Every discovery serves as another piece fitted into the grand cosmic puzzle, and this quest has fueled the passion of countless people, from amateur enthusiasts to world-renowned scientists. The desire to locate and examine these objects from space has sparked innumerable expeditions and led to historic finds. From the very first documented meteorite, which fell in Egypt over 3,000 years ago, to the latest specimens recovered from Antarctica, the chronicle of this search is rich with adventure. It's important to pause and consider the deeper meaning of these discoveries, as they not only enhance our understanding of our own world, but also forge a tangible connection to the immense cosmos surrounding us. Each meteorite serves as a potent reminder that we are inhabitants of a much larger and more enigmatic universe. So, the next time you glance at the night sky and witness a falling star, consider that it might just be the start of a thrilling new adventure, an invitation to delve into the universe's past and unlock its secrets. When you gaze up at the night sky, you are looking at an immense ocean of stars, planets, and of course, meteorites. But have you ever stopped to think about what becomes of these fragments when they journey to other planets, like Mars? The scientific investigation of meteorites on other worlds is a captivating field that can unlock secrets about the solar system's ancient history. On Mars, for example, meteorites are genuine cosmic voyagers that have traveled billions of kilometers to settle on its surface. But how can we be certain these rocks are truly Martian in origin? The answer is found in their distinct chemical and mineralogical signatures. It's as though each meteorite carries a cosmic passport detailing its entire life story. Martian meteorites that have landed on Earth are primarily categorized into three main types: shergottites, knocklites, and chassignites. Each group possesses its own unique composition and history, much like different regions of a single country. Shergottites, for instance, are geologically young, having formed only a few 100 million years ago, whereas knocklites date back about 1.4 billion years. This diversity offers us a window into how Mars has transformed throughout its long geological past. One of the most fascinating aspects of Martian meteorites is the story of their formation. These rocks were violently launched from the Martian surface by events like massive volcanic eruptions or powerful asteroid impacts, sending them on a long journey through space before they ultimately arrived on Earth. You can think of Mars as a vast garden, and these meteorites as seeds flung into the cosmos, capable of taking root on distant soil. Each new discovery opens another portal to an ancient and unexplored past. The study of these extraterrestrial stones has also enabled scientists to gain a deeper understanding of Mars's climate history. Through the chemical analysis of these meteorites, researchers have found evidence of water and other key elements, which suggest that Mars might have been a much wetter world long ago. This discovery naturally leads to compelling questions. What happened to all the water on Mars? And could life have ever emerged there? Every answer we find seems to uncover even more questions, as if we are slowly deciphering an age-old enigma. One significant challenge that scientists grapple with is the task of correctly identifying Martian meteorites here on Earth. Because they often look very similar to other meteorites originating from asteroids, distinguishing them can be quite difficult. This is precisely where modern technology becomes indispensable. Sophisticated analytical tools play a crucial role in confirming the unique identity of these rare visitors from the red planet, allowing us to confidently read the stories they have to tell.
To unravel the secrets locked within each meteorite fragment, scientists employ sophisticated instruments to analyze their isotopic composition, almost like using a high-powered microscope. This advanced technology enables them to reconstruct the history of these celestial visitors and chart their long voyage from Mars to our world. Yet the search is not confined to Earth. Space missions, including rovers traversing the Martian landscape, are also actively hunting for meteorites, navigating a difficult and obstacle-ridden terrain, much like explorers in a dense jungle. Every meteorite discovered on Mars offers profound insights not just into the red planet itself, but also into the formative processes that shaped our own world. As our exploration of the cosmos expands, the prospect of finding meteorites on other celestial bodies grows ever more compelling. You might consider Jupiter's moon Europa or Saturn's moon Enceladus, where conditions are thought to be favorable for life, and imagine the incredible stories meteorites from these locations could tell. Stories we can currently only dream of. What truths might meteorites from these remote worlds unveil about the potential for life elsewhere in the universe? The hunt for these objects extends far beyond Mars, as scientists are deeply interested in studying them on asteroids and comets as well. These bodies are often seen as pristine time capsules, holding preserved information from the very dawn of our solar system. And by studying them, researchers can piece together the story of planetary formation and the evolution of our cosmic neighborhood. Investigating meteorites on other planets also holds immense importance for the future of space mining. Should we one day decide to harness the resources of other worlds, these celestial objects could serve as a rich source of metals and minerals. You can picture meteorites as cosmic treasure chests drifting through space, filled with precious materials just waiting for us to find them. This endeavor of space mining has the potential to fundamentally alter our relationship with the cosmos and unlock new frontiers for human development. However, undertaking the study of meteorites on other planets is fraught with significant hurdles. The technology needed to retrieve and analyze these objects in space is both extraordinarily complex and prohibitively expensive. Moreover, missions to explore these distant worlds demand immense investments in time and meticulous strategic planning. But every advancement in this domain brings us a step closer to understanding our true place in the universe. Ultimately, meteorites found on other planets, particularly Mars, serve as carriers of ancient narratives that help us comprehend not only the history of our solar system, but also the destiny of Earth. Each fragment that lands here establishes a physical link to other worlds, and ongoing research continues to expose secrets that could reshape our entire conception of the cosmos. This remarkable connection between Earth and Mars via meteorites is a powerful reminder of our shared existence in this immense cosmic tapestry, where each new find is another stride towards self-awareness. Have you ever considered what it would be like to hold a cosmic fortune in your hands? This is the very essence of space mining, the prospect of extracting valuable materials from the meteorites that journey through our solar system. These ancient celestial travelers are far more than just drifting rocks. They are genuine time capsules that can contain precious metals and other substances of great utility for humanity. But how could you transform this ambitious idea into a practical reality? To begin, it's crucial to understand which types of meteorites would be targeted for mining operations. Some are metallic, abundant in iron and nickel, while others are stony and may harbor valuable minerals like gold, platinum, and other rare earth metals. You should think of each of these objects as a miniature cosmic mine, packed with resources that are increasingly challenging to source on our own planet. The key question then becomes how we can determine which of these meteorites are truly worth the effort of mining.
The solution to that question lies in dedicated research, with space missions increasingly designed to identify and categorize these celestial bodies. You might also ask about the economics of such an endeavor. This is where science and technology converge. It is projected that as our exploration and extraction capabilities advance, the expense of gathering materials from meteorites could become competitive with traditional mining here on Earth. The potential rewards are immense, as meteorites could contain metals that are quite scarce on our planet. For instance, platinum, a vital component in numerous industrial applications, might be sourced more affordably from these cosmic bodies. Furthermore, having access to these materials in space could be absolutely essential for future missions to Mars and beyond. Just imagine constructing extraterrestrial habitats using resources mined directly from nearby asteroids. The prospect is nothing short of incredible. However, the path to space mining is not without its own set of significant challenges, particularly the technology needed to extract these resources efficiently. We are currently in the initial phases of creating the necessary tools, from robotic systems capable of drilling into meteorite surfaces to transportation networks that can ferry these materials back to Earth. In this endeavor, international collaboration will be absolutely essential. Much like deep-sea exploration or polar research, efforts in space mining will demand a unified approach from various nations and private organizations, guided by new treaties that regulate the use of space resources. One of the most thrilling dimensions of space mining is the concept of in situ resource utilization, which means we could use materials found in space to directly support future missions. This would drastically lessen our dependence on Earth and greatly facilitate the colonization of other planets and moons. Imagine a future where people are living and working on Mars, sustained by materials sourced from local asteroids. This vision is not just exciting, it unlocks limitless potential for our species as we look to the stars. The knowledge we gain from studying and utilizing meteorites could provide solutions to some of the most critical challenges we face here on Earth. This pursuit of celestial objects also revitalizes public interest in both education and scientific exploration. Every new fact we uncover about these bodies from space brings us a step closer to deciphering the origins of our solar system and the complete story of our own planet, which shows that space mining is about far more than just gathering resources. It's about unlocking the universe's greatest secrets. The prospect of mining meteorites is no longer confined to the realm of science fiction. It is becoming a plausible reality that has the potential to completely reshape our relationship with space. As we make progress in this domain, it will be fascinating to observe how humanity adapts to harness these extraterrestrial materials and to see the profound effects this will have on our future. The real question now is whether we are truly prepared to begin this cosmic journey and find out what treasures are waiting for us in the immense void of the universe. Throughout the history of our world, meteorites have left an unmistakable imprint. Their arrivals on Earth have often been seen as terrifying events, yet they have also produced captivating and occasionally beneficial outcomes. Without a doubt, one of the most pivotal moments in our planet's timeline was a meteorite impact. But how can we be certain that these cosmic collisions have so profoundly shaped our world and its development? You can think of meteorite impacts as powerful storms that batter a ship navigating the open ocean. Just as a squall can divert a vessel from its intended path, these cosmic collisions have fundamentally redirected the course of our planet's history. For instance, the scientific consensus is that a meteorite approximately 10 kilometers wide triggered the extinction of the dinosaurs. This cataclysm, known as the Cretaceous-Paleogene extinction event, took place around 66 million years ago and brought a definitive end to an entire geological era. So, what precisely occurred during that catastrophic event? The impact from this enormous meteorite liberated an amount of energy comparable to billions of atomic bombs.
This collision produced such intense heat that it sparked massive wildfires across the globe and flung immense quantities of dust and debris into the atmosphere, which veiled the sun for months. The subsequent darkness led to a dramatic fall in global temperatures, causing a total collapse of Earth's ecosystems. Yet, the dinosaurs' demise created a crucial opening for the evolution of mammals, which eventually led to the appearance of human beings. Therefore, while the impact was utterly devastating, it also served as the catalyst for life as we currently know it.
Beyond their role in mass extinctions, meteorite impacts have also been responsible for creating craters, which you can think of as permanent scars on the face of our planet. One of the most famous and largest of these is the Chicxulub crater, located in Mexico. This immense formation stands as a physical testament to the collision that irreversibly altered the trajectory of life on Earth. This leads us to wonder what other craters exist and how they have molded the geography of our world. A crater might appear to be a mere hollow in the ground, but each one is a rich historical document of our planet's past. Every time a meteorite strikes, it leaves behind a signature that scientists analyze to understand both the impact event itself and the environmental conditions that prevailed on Earth at that moment. These craters, in essence, speak to us about the distant past, revealing how our continents and oceans were reshaped by cosmic forces. Along with these massive collisions, we also need to account for the smaller meteorites that rain down on our planet daily. Even though most do not form large craters, their effect on the environment can still be considerable. For example, certain meteorites are composed of materials that can generate thunderous explosions upon entering our atmosphere, a phenomenon we call a meteor. And while the impact of a single meteor is far less dramatic than that of a large meteorite, they occur with vastly greater frequency. The chronicle of meteorite collisions naturally leads us to contemplate the subject of planetary defense. Today, scientists have devised sophisticated systems for tracking potentially hazardous objects that could pose a threat to Earth. This effort is comparable to a team of lookouts scanning the sea for any approaching ships. With modern technology, we can now detect and analyze these objects, calculating their trajectories and evaluating the level of risk they represent to us. But what would happen if we found a meteorite on a direct collision course with our planet? The thought of a future impact brings up some unnerving questions, such as whether we are adequately equipped to handle a new extinction-level event. Fortunately, breakthroughs in space technology have enabled us to consider viable solutions, including methods to deflect an incoming meteorite. While that may sound like a plot from a Hollywood movie, scientists are currently working on tangible strategies to protect our home. It is also crucial to recognize that not all cosmic impacts are disastrous. Over the course of history, some meteorites have delivered precious materials to Earth, fueling human curiosity and making significant contributions to scientific discovery. You can view meteorites as cosmic couriers, carrying secrets about the solar system's origins and the makeup of distant worlds. Each one provides us with clues to better understand our own place in the cosmos. Ultimately, the history of meteorite collisions is an epic saga that stretches from the formation of ancient craters to the very evolution of life on our planet. Every impact event is like another chapter in a vast book that narrates the story of Earth. As our research presses forward, each new discovery brings us closer to comprehending our unique position in the universe and what other revelations these fascinating cosmic travelers might hold. To conclude, meteorites are far more than just simple rocks that fall out of the sky. They are the silent witnesses to cataclysmic events that have sculpted our world and shaped the life we know today. From their destructive consequences to their potential for sparking new avenues of research, meteorites are a constant reminder that the universe is a place filled with surprises and deep mysteries.
Our planet's story is inextricably linked with the journeys of these celestial wanderers, and every new finding is an invitation to explore and better understand our world and the vastness beyond it. The subject of planetary defense is truly captivating, as it connects us directly to the universe and serves as a stark reminder that cosmic forces could alter our existence in a moment, despite the relative safety of our world. Are you aware that thousands of objects hurtling through space, including asteroids and comets that sometimes become meteorites, could intersect with Earth's orbit if their paths were to shift? This raises a critical question. What are we actively doing to shield ourselves from such a possibility? Imagine you are outside on a tranquil evening, gazing at a clear, star-filled sky, when a brilliant streak of light suddenly cuts across the darkness. While this may appear to be a breathtaking celestial event, a phenomenon just like it could represent a significant threat. Scientists are therefore working tirelessly to identify and categorize these near-Earth objects. In essence, planetary defense functions like a sophisticated early warning system, designed to alert us to potential dangers from the cosmos. The very first line of defense in this system is a global network of powerful telescopes. These instruments are strategically positioned around the planet with the singular mission of scanning the heavens for asteroids. You can picture them as sentinels on a cosmic watchtower, searching the immense expanse of space for small fragments of rock that have the potential to become a very large problem for us here on Earth. But discovering an approaching asteroid is only the beginning of the process. The subsequent challenge for scientists is to meticulously calculate its trajectory, a task that is as complex as it is crucial, almost like trying to predict the future. Once a potentially hazardous asteroid is flagged, an intensive series of calculations and computer simulations gets underway to ascertain whether there is any genuine risk of a collision with our planet. Should an imminent threat be confirmed, a variety of different strategies are brought into consideration. One of the most fascinating of these is the concept of asteroid deflection. Picture a massive truck moving down a highway. To alter its course, one might use another vehicle to push it. Scientists are developing analogous technologies for asteroids, proposing to send a spacecraft to intentionally collide with one and thereby shift its trajectory, not unlike a game of cosmic billiards. To determine if such a feat is genuinely achievable, several missions are currently under development to test these very techniques. A prime example is the Double Asteroid Redirection Test, or DART mission, which was designed to crash a spacecraft into an asteroid to measure how much its path could be altered. This naturally leads to the question of what our options would be if we were unable to deflect an incoming object, and the answer to that is equally compelling. Scientists are researching ways to mitigate the consequences of an impact, which could involve evacuating populations in danger zones or constructing specialized shelters, though prevention clearly remains the best defense. Another vital component of planetary defense is international cooperation. The Earth is our shared home, and when we are faced with a threat from space, collaboration among nations is absolutely essential. The philosophy behind several international treaties is to coordinate a unified global effort for monitoring and protecting against asteroids, uniting all countries against a common danger. This spirit of cooperation is turning concepts once relegated to science fiction into a tangible reality. While these technological strides are undeniably impressive, it's fair to ask just how prepared we truly are. The reality is that most of us remain unaware of the full scale of the threat that celestial impacts represent. This is why public education is so crucial, and it's a primary reason scientists and educators are working diligently to inform people about the importance of planetary defense. As we explore this topic, it's also worth looking back through history, as humanity has witnessed catastrophic events caused by cosmic collisions.
The famous Chicxulub impact event, for instance, is widely believed to have been a contributing factor in the extinction of the dinosaurs, offering a profound lesson from our planet's past that can help us safeguard its future. Consequently, the search for and analysis of meteorites not only expands our understanding of the universe, but also equips us to handle future threats. Every new discovery provides critical data, making the study of meteorites less of a scientific curiosity and more of a fundamental necessity for our survival. In conclusion, planetary defense is a rapidly advancing field that merges science, technology, and global partnership. As our knowledge deepens and our capabilities expand, so too does our responsibility to protect our world. So, the next time you look up and see a shooting star, I hope you'll remember that behind its fleeting glow lies a massive, collective human effort dedicated to ensuring the continued safety of our planet from the hazards of space. It's also important to recognize that meteorites are not just fascinating cosmic curiosities. They have also been instrumental in the development of modern technology. Did you know that a great number of advances in materials science and other processes can trace their origins back to the study of these celestial travelers? I want to explore with you some of the unexpected ways meteorites have shaped our technological world. In the realm of metallurgy, for example, certain meteorites are composed of rare metals that are exceptionally difficult to find on Earth. By studying these extraterrestrial samples, scientists have gained a deeper understanding of how these metals behave under extreme conditions, which has directly led to the invention of alloys that are both stronger and lighter. You can think of it as a master chef experimenting with exotic ingredients delivered from the far reaches of space to create an entirely new kind of cuisine. The study of meteorites has also spurred significant improvements in detection technology. Scientists are currently engineering sophisticated sensors capable of determining the precise chemical composition of a meteorite as it enters our atmosphere. This process is almost like having a cosmic nose that can identify the specific type of object approaching us. Such technologies are not only invaluable for scientific research, but also have practical applications in the security and space exploration industries. Another fascinating area of influence is in imaging technology. When researchers analyze a meteorite, they employ advanced imaging methods that permit them to see the object's internal structure in incredible detail. You can imagine having a superpowered microscope that can peer deep inside these ancient rocks, revealing the hidden secrets and cosmic history locked within them. This kind of technological transfer is also permeating other disciplines, such as medicine, where advanced imaging scanners are employed to spot diseases at their most nascent stages. It shows that the insights we gather from meteorites extend far beyond the astronomical field, directly contributing to the betterment of human health. Moreover, meteorites have become a wellspring of inspiration for the invention of novel materials. The study of minerals exclusive to certain meteorites, which are not native to our planet, has spurred the creation of groundbreaking materials with unique characteristics, like enhanced resilience to high temperatures. This pursuit is not unlike an artist's quest for new pigments to use in their work, demonstrating that answers can often be discovered in the most unforeseen places. The aerospace industry stands as another domain that has profited immensely from the examination of meteorites. Through a detailed understanding of how these space rocks erode and break apart when they enter our atmosphere, engineers are better equipped to construct spacecraft resilient enough to survive the unforgiving conditions of space. For instance, the very technology behind heat shields was informed by observing the behavior of meteorites during their fiery descent. It is almost as if meteorites are providing us with direct counsel on how to safeguard ourselves from the hazards of space exploration. The energy sector has also been influenced by these celestial visitors, as some research indicates that specific compounds within meteorites
could form the foundation for new power sources. This line of inquiry could pave the way for more effective batteries or perhaps even entirely new categories of renewable energy. In the same way that inventors seek innovative uses for natural resources, scientists are looking skyward for solutions embedded in the universe's ancient past. Nanotechnology is yet another field where the influence of meteorites is evident. By examining the molecular-level structures within these objects, researchers have pioneered new techniques for fabricating materials at the nanoscale that are both stronger and lighter. You can think of it as constructing a building with minuscule bricks that, when combined, create a structure far more robust than one made with conventional methods. The future of technology and construction may very well be locked within the secrets these cosmic bodies hold. Nanotechnology is yet another field where the influence of meteorites is evident. By examining the molecular-level structures within these objects, researchers have pioneered new techniques for fabricating materials at the nanoscale that are both stronger and lighter. You can think of it as constructing a building with minuscule bricks that, when combined, create a structure far more robust than one made with conventional methods. The future of technology and construction may very well be locked within the secrets these cosmic bodies hold. Even artificial intelligence has gained from the analysis of meteorites, as the data extracted from them is used to train algorithms that can forecast the movement of celestial objects. Imagine you had an assistant capable of predicting patterns and behaviors across the cosmos. This capability is not only useful for tracking meteorites, but also has applications in fields like meteorology and real-time data analysis. When you consider space travel, the study of meteorites has been indispensable for orchestrating missions to other planets. Knowing how meteorite impacts have shaped the surfaces of other worlds allows us to better prepare for future voyages of discovery. Every mission represents a leap into the unknown, with meteorites acting as our cosmic maps to guide us through this journey. It's truly remarkable to consider that while meteorites originate from space, their impact is profoundly felt right here on our own planet. Many of the technologies you rely on daily, from your smartphone to your computer, might trace their origins back to the study of these celestial travelers. In a way, meteorites have played a part in the technological revolution that defines our modern era. As our comprehension of the universe deepens, you can be sure that meteorites will continue to be a source of invaluable knowledge and technological innovation. Each fresh discovery unlocks a door to new questions and even greater possibilities. It is human curiosity, fueled by the investigation of these captivating objects, that will propel us further into our exploration of the cosmos. Ultimately, the link between meteorites and technology serves as a potent reminder that something seemingly distant and alien can have a direct and meaningful effect on our everyday existence. So, as we turn our gaze to the heavens in search of answers, we are simultaneously forging a more advanced future for ourselves here on Earth. The trajectory of meteorite research is a thrilling subject that ignites both wonder and curiosity. With every new finding, we inch closer to resolving fundamental questions about our own position in the universe. What mysteries do these cosmic voyagers still conceal? The solution to that question has the potential to reshape our entire understanding of planetary formation and the very genesis of life. Advances in technology have unveiled new frontiers in the field of meteorite studies. For instance, sophisticated space telescopes and interplanetary probes now permit scientists to observe and scrutinize meteorites with a level of detail that was previously unimaginable. Just picture the ability to watch a rock that is billions of years old as it travels through space, a feat now achievable thanks to modern technology. But how are these technological breakthroughs being applied to the study of meteorites in practice?
One of the most compelling approaches involves asteroid exploration missions. Ventures like Japan's Hayabusa probe and America's OSIRIS-REx have successfully landed on asteroids, gathered samples, and transported them back to Earth for in-depth analysis. These missions are akin to miniature expeditions into our solar system's past, where each particle of collected material narrates a unique chapter of that history. In laboratories back on Earth, scientists employ cutting-edge techniques to analyze the isotopic composition of these meteorites. This analytical process is like assembling a complex puzzle, with each isotopic piece offering vital clues about the origin and history of these celestial bodies. Isotopes can unveil precise details about where a meteorite came from and the conditions that prevailed during its formation. As the scientific community makes progress, fresh inquiries naturally emerge. For example, how might meteorites guide the search for life on other planets? The Mars Sample Return mission, designed to bring Martian samples to Earth, intends to explore whether any collected meteorite fragments contain evidence of past biological activity. The chance of finding life on another world is a dream that has captivated humanity for centuries, and such a discovery would fundamentally alter our perception of the universe. Looking further ahead, into the realm of space mining, meteorites could also represent a significant source of valuable resources. The question I often hear is about the distinction between a meteoroid, a meteor, and a meteorite, and the answer reveals a fascinating cosmic journey. You can picture a meteoroid as a piece of rock or metal adrift in the vastness of space, essentially a small fragment broken off from a larger asteroid or comet. When that object's path intersects with our world and it streaks through the atmosphere, friction causes it to ignite. And at that moment, you see it as a meteor, what many call a shooting star. If a piece of that object survives the fiery descent and physically lands on the Earth's surface, it earns its final name, a meteorite. Here's a fact that might surprise you. Many meteorites are actually older than our own planet. It's hard to wrap your head around, but these celestial objects formed in a much earlier phase of our solar system's development, making them genuine time capsules from a period before the Earth even existed. By analyzing them, scientists can access direct evidence of the conditions and materials that were present during the solar system's chaotic birth, almost like reading the pages of a history book from a time long past. This leads to another critical question. Why are meteorites so vital for comprehending the origins of life on Earth? The answer lies within a compelling hypothesis suggesting that these ancient stones may have acted as cosmic couriers, delivering the essential ingredients for life to our nascent planet. You can imagine space as a vast celestial kitchen, and meteorites were the vehicles that brought crucial elements like water and complex organic compounds, which, under the right conditions, could have sparked the beginning of life itself. Delving deeper into that idea, the connection between meteorites and the water on our world is a profound mystery that scientists are actively exploring. A prominent theory proposes that Earth was once a dry, barren rock, and it was a relentless bombardment by water-rich meteorites that delivered the precious liquid necessary for life. It's a powerful image. The first rains to ever fall on Earth may have arrived from space, carried within these rocky travelers, ultimately creating the oceans we know today. Now, you might wonder why certain meteorites are considered more valuable than others. Their worth is determined by a combination of their unique composition and their specific point of origin. For instance, meteorites that have been confirmed to come from the Moon or Mars are exceptionally rare and provide us with invaluable information about those celestial bodies without the immense cost of a sample return mission. Their value is rooted not just in their material, but in the extraordinary history they carry within them. So, how do researchers actually locate and analyze these cosmic treasures?
The methods for finding them are quite varied and demand a great deal of patience. Scientists might track the bright flares of meteors in the night sky to predict a landing zone, or they might conduct systematic searches in environments where meteorites are easier to spot, such as the vast, empty deserts of the world, or the pristine ice sheets of Antarctica, where a dark rock stands out clearly.
Beyond just studying what falls to Earth, there's a growing excitement around the topic of space mining. Experts believe that some asteroids, the parent bodies of meteorites, are packed with rare elements and precious metals that are in short supply here. Imagine a future where we could harness these resources directly from asteroids, using them to construct technology for space missions, or even to supplement our resources back on Earth. This could truly open a new chapter in human innovation. Of course, our relationship with these space rocks has a much more serious side. While they are a source of knowledge and potential resources, they also represent a significant threat. The field of planetary defense is dedicated to understanding and mitigating the risk of a major impact. Every meteorite we study gives us more data on composition and trajectory, helping us develop more effective strategies to protect our world from a future collision with a large asteroid. Facing such a cosmic challenge is far too great a task for any single nation, which is why international collaboration is absolutely essential. The future of meteorite research and planetary defense depends on countries sharing their data, technology, and resources to accelerate our collective progress. In a scientific endeavor where borders are meaningless, combining our global efforts is the only way to achieve the breakthroughs needed to understand our solar system and ensure our safety. It's also interesting to see how our perception of meteorites has been shaped by popular culture. Films, novels, and video games frequently feature these objects, sparking your imagination about the mysteries and dangers of space. This cultural fascination has cultivated a widespread public interest in astronomy, which in turn helps drive the political and financial support required for new scientific missions and research projects. Ultimately, it's crucial for you to remember that every single meteorite that reaches our planet is a unique opportunity for discovery, as each one carries its own distinct narrative. As our research capabilities advance, we slowly unravel the complex history of our solar system, one stony messenger at a time. This journey of investigation not only helps us understand our distant past, but also gives us the knowledge to navigate our future as we venture further into space. As we look ahead, it's clear the future of meteorite research is filled with incredible potential. With every technological leap and each new space mission, we peel back another layer of the universe's grand design. This quest is more than a scientific adventure. It is a profound exploration that connects you to the cosmos, offering a humbling reminder of our place in the vastness of space. As we continue this journey, you'll see that the sky is not our limit, but only the very beginning. Whenever you gaze up at the night sky, you're faced with an immense cosmos, brimming with wonders and unanswered questions. During our journey, we've explored the captivating story of meteorites and their fundamental role in forging our solar system. This raises a critical question. Why does understanding these celestial travelers matter so much? What profound truths can they unveil about our planet's beginnings, and, by extension, about our own existence? You can think of meteorites as ancient chronicles that have journeyed across space and time, bearing tales from the distant past, allowing scientists to decipher our cosmic history. You might be asking if meteorites truly have a connection to the water found on Earth, and the answer is an astonishing yes. These celestial objects were instrumental in transporting water to our world, and by analyzing their makeup and origins, we move closer to solving the puzzle of how life first started. Furthermore, some hypotheses propose that these very fragments may have carried the building blocks required for life itself to arise, suggesting the tantalizing possibility that they seeded our planet with life's precursors during their interstellar voyages. We've come to understand that meteorites are not all alike. They come in various types, each with a distinct narrative to share. Ranging from stony to metallic compositions, every meteorite provides a unique window into the processes that formed our solar system. Scientists can even identify the most ancient among them, some of which have journeyed for billions of years, offering a direct glimpse into the dawn of our cosmic neighborhood by revealing secrets from its earliest moments. The cataclysmic impact, thought to have wiped out the dinosaurs, serves as a powerful reminder that meteorites present both marvels and serious challenges. These events have left their mark on our physical and cultural history, teaching us about our planet's vulnerability and the sheer scale of the universe. This shows that the cosmos constantly urges us to be ready for the unforeseen, making planetary defense a subject we cannot afford to overlook. As our knowledge of their flight paths grows, scientists are intensely focused on identifying and neutralizing these risks. And just as nations must band together like firefighters against a massive blaze, global collaboration is essential. This brings us to a critical question. What lies ahead for meteorite research? With new space missions and breakthroughs in exploration technology, the field is poised to unlock even deeper secrets about the solar system's origins, the delivery of water, and life itself. The inquiries surrounding these celestial objects are as captivating as the objects themselves, with every answer paving the way for further investigation. It feels as though we are about to turn the first page of an entirely new chapter, with each discovery bringing us closer to understanding not just our world, but our place within the cosmos. The study of meteorites is vital, not just for comprehending our history and current reality, but also for unlocking future opportunities, such as the potential for space mining. As humanity's reach into space expands, these celestial bodies are increasingly viewed as potential repositories of precious resources. Consider a future where essential materials for constructing habitats on other worlds are sourced directly from meteorites, a concept that could completely transform how we approach cosmic exploration. In the end, meteorites are profoundly more than mere rocks from the sky. They are carriers of essential information connecting us to our past and inspiring our future exploration. Every meteorite contains a unique narrative, and their significance is woven into our culture, our history, and our unceasing quest for knowledge. So, the next time you witness a meteor blazing through the atmosphere, I want you to see it as more than a fleeting streak of light. Recognize it as a testament to the universe's magnificence, and a prompt that our journey of discovery has only just begun. These celestial visitors offer a unique glimpse into our cosmic origins, provide clues to our collective future, and serve as a profound source of inspiration for us all. The next time you witness a meteor blazing across the darkness, remember that you are seeing more than just a fleeting natural event. You are experiencing a direct link to a history that extends across billions of years. This powerful connection truly captures the essence of meteorites and underscores their immense importance in expanding our comprehension of the cosmos.